substitution. Essential question. How do you determine what to substitute in a system of equations? The vocab word for this lesson is substitution. I'm not actually going to define it. I'm just going to tell you that that's the method we're going to use. We're going to be substituting something in from one equation into another for this method. So far, you guys know how to solve a system of equations by graphing. And then there are two other methods you're going to learn. You're going to learn substitution in this lesson and then elimination in the next two lessons. Here's just a review of the charts with the different possibilities for solutions. So we have parallel lines, intersecting lines, and identical lines. So I'll bring those three terms up into the describing the lines: identical, parallel, and intersecting. Parallel lines never touch one another, so they have no solutions. Intersecting lines cross each other once, so there's one solution. And identical lines touch each other an infinite number of times, so it's infinitely many. Now for our equations, if the lines are identical, they have to have the exact same slope and the exact same y-intercept. If the lines are parallel, the slope has to be the same because we learned back in chapter 4, parallel slopes stay the same. Intersecting lines have one positive and one negative slope because they cross one another, so they need to have different slopes. All right, here's the first example. Use substitution to solve the system of equations. So we're going to look at both of these equations and look for where we have a variable all by itself on one side. So this y right here is all by itself on one side. So I'm going to circle what y equals, which is 7 minus x. Now this method is called substitution because we're going to substitute the 7 minus x in for y. Now to make this a little easier, let's pretend y equaled 5. And what if I asked you, where would you put that 5 into the bottom equation? You'd put it in for the y. But we're taking the entire 7 minus x, because we have y equals 7 minus x, not 5. So we're going to take that entire 7 minus x and put it in for y. So I'm going to write 2x minus, and then I have 7 minus x equals 8. Now the tricky thing about this one is that minus in the middle. I'm going to turn that into a -1, and then I'm going to distribute it. So I'm going to have 2x minus 7 plus x equals 8. Because -1 times 7 is -7. -1 times -x is positive x. Now I know I did this right if I only have one variable in my problem and I just have x's. The y's are gone, so I know that I did this correctly. So let's keep going by combining same side-like terms. So 2x and x make 3x. And now we just have a couple and third wheel problem. Our couple is 3x, add 7 to both sides. 8 and 7 make 15. If I break up my couple, I get x equals 5. Now the thing is, we're not done with this problem. We're only halfway done with it. And that's because we're trying to end up with a coordinate point to see where they intersect. So I'm going to take 5 and plug it back into x in one of my equations. I think the easiest thing is to plug it into the x in the circle. So I'm going to take it and plug it in right there in for that x. So y equals 7 minus, and then instead of x, I'm going to put 5. 7 minus 5 is 2. Now I have a coordinate point. So my final answer, x always goes before y, so I'm going to write this coordinate point as 5, 2. Since I ended up with a coordinate point, we know that if we graph these lines, they'd have to be intersecting and one solution, because the only time we end up with a coordinate point is intersecting one solution. Everything you're going to do in this lesson, or in today's day 1 of substitution, is going to be intersecting one solution. So if we took both of those equations and graphed them, they should intersect at the coordinate point 5, 2. All right, second example. Again, I'm going to look for where do I have a variable all by itself on one side, and that's this y. So I'm going to circle what y equals, which is 2x plus 1. Since this is a y, I'm going to plug it in for y in my equation below. So instead of writing y, I'm going to replace it with 2x plus 1. So I'll start from the left. 3x plus, and now instead of y, I'm writing 2x plus 1 equals negative 9. Now I know I did this correctly if I only have one variable, which I do, I just have x. The y is gone. 3x and 2x make 5x. And then it's just couple and third wheel. So subtract 1 on both sides. Negative 9 and negative 1 make negative 10. Divide both sides by 5. And I have x equals negative 2. Now I'm not done. That's only half of my answer. So I have to take negative 2 and plug it back into my x. And I usually do it in my circle. You can do it in the other equation, but the circle is the easiest and quickest way to do it. So I'm going to write y equals 2, and then instead of x, I'm going to write negative 2 plus 1. Negative 2 times 2 is negative 4. Negative 4 plus 1 is negative 3. So my coordinate point for my answer for this one is negative 2, negative 3. Since I got a coordinate point, it would be intersecting one solution. So if I graphed both of those equations, I would end up with two lines that intersect at the coordinate point negative 2, negative 3. All right, x plus 2y equals negative 6, and x equals y plus 3. This time the variable I have all by itself on one side is x, but we're still going to do the same thing. I'm going to circle what x equals, but instead of plugging it in for y, I'm going to plug it in for x. So I'm going to take this top equation, and instead of writing x, I'll write y plus 3. Then I just continue the rest of the equation. Plus 2y equals negative 6. I know I did the first step correctly if I only have one variable, which I have y and 2y, no x's, so I did it correctly. Y and 2y make 3y. And then it's just couple and third wheel. Minus 3 on both sides. And then divide both sides by 3. So now I'm going to take negative 3 and plug it back into y in my circle. So x equals negative 3 plus 3, which negative 3 plus 3 is 0. So my coordinate point for where my two lines would intersect is 0, negative 3. I would write intersecting one solution. This time, this problem looks a little bit different because we have two variables that are alone. We have this y and that y. You can pick which one you want to circle. It doesn't matter. So I'll just pick this bottom one. Since it's y equals, you're going to plug it in for y in the top equation. So I'm going to replace y with 3x plus 1. And then I'll write in 2x minus 4. I know I did this correctly if I have just one variable. Now this one looks a little different because we have a variable on both sides. We know when we have a variable on both sides, we need to get it on the same side. So we can minus 2x on both sides or minus 3x. It doesn't matter. I always like to keep things positive. And then to get x by itself, subtract 1 on both sides. Negative 5. Then I'm going to take negative 5 and plug it into the x in my circle. So y equals 3 times negative 5 plus 1. 3 times negative 5 is negative 15. Negative 15 plus 1 is negative 14. So my coordinate point where my two lines would intersect is negative 5, negative 14. Remember, we always go x then y. So if you've been confused about what order to put the coordinate points, order of the alphabet, every coordinate point goes x then y. Summary. The homework for this lesson isn't going to be the book assignment, it's going to be a worksheet. So just ignore this right here.